Hello, everybody. This is Mr. Reese. I had some students come by and they were asking questions about subtracting vectors and also multiplying vectors by a scalar. And I just wanted to do another quick video here to help you out with that. So let's start with some vectors. Let's say a vector A. And here we go. Remember, we can put a little hat on vector A. And let's say vector A is equal to 5. Okay, so to be clear, vector negative A would look like this. So vector negative A is the exact opposite direction of vector A. It's also worth 5. It's just pointed in the opposite direction. Okay, and that's important to know. So if you ever have a negative vector, it's just the same size but in the opposite direction. Here's why that matters, okay? Let's say B was also 5 and pointed straight up. So then I'd like you to draw negative B. So pause the video and draw yourself negative B. And I'll go ahead and do that now. So negative B, of course, would be like this. It's also 5, but it's pointed down. So we learned on the last video how to add vectors. So let's just kind of redo that. So let's say I put my coordinate system on here. We always put a coordinate system when we're adding vectors. And this is graphically adding them. I'll change colors so you can easily see this. So let's say we did A plus B. So A would be like this, and B, which is the one that goes up, would be like this. So this is A, this is B. And so, of course, from tail of the first vector to the head of the last vector is A plus B. But people are more curious, well, what about A minus B? What does that look like? And the best way to think about this is A minus B is the same thing as saying A plus negative B. And we already know now negative B is just this. I'll do this one in blue. So if we do A plus negative B, you start with A again. And now you're going to add negative B. So negative B is like this. Negative B. We're adding it to A, and you end up with this. So that is A plus negative B, which is equal to A minus B. In other words, subtraction is the same as addition, except you're adding the negative of the vector you're subtracting. And so you just add it the same way. So really you only have to learn addition is the point of this lesson. And addition is always the same way. You draw the first vector, and then you put the second vector's tail at the head of the first vector. And then the resultant is going to be from the tail of the first vector to the head of the second vector, or the last vector. And so if you're going to do subtraction, just add the negative of the vector, and you just add it the same way. Okay? All right, so that's one quick little lesson. I want to show you one more thing. Let's say you had vector. Let's try vector, we'll do vector D. And if this is my coordinate system, let's say vector D is actually like this. Let's say it's 10 units long, and let's say this angle happens to be 45 degrees. Okay. So remember, D has a magnitude of 10. And the way you can actually, magnitude is a fancy word for size. The way you can just talk about the magnitude is you can put the vector in absolute values. And so we can say vector D is equal to 10. Another thing you should know about kind of describing these vectors mathematically is you can really call the angle as a reference angle from the positive x-axis all the way around. And so in this case, of course, this is 90 plus another 90, 180 plus 45. So this angle is 225 degrees. So you could say vector D is equal to 10, and I usually do at 225 degrees. That's one way to describe vector D. Another way to describe vector D, that was bothering me. Another way to describe vector D is to describe it with a negative angle. So this angle is, of course, the 90 plus another 45, so it's negative 135 degrees. So we can also say 10 at negative 135 degrees. And that's also the true. Vector D can be said like that. But most people actually talk about vectors in terms of their x and y components. So we can find dx now and dy now. So using, I guess I'll go to green. So if that's d over here, remember this is dx and this is dy. Notice how the x goes on the x-axis and the y goes on the y-axis. That makes sense. So it's the vector in the x. And you can kind of think, let's say there was a light shining right here. Maybe it's the sun or something like this. So we just have the eclipse. And it's shining light this way. You would get a shadow in this region. That's the x component. It's the shadow of the vector onto the x-axis is the x component. And if you instead had a sun over here, shining light this way, and I don't know, maybe it actually makes, I mean, you could do the light shining this way. Of course, you would have a shadow over here. But you could also think of the sun over here. Let me switch this color. There it goes. Over here, shining this way, and it would project a shadow on this axis, of course, and equal to dy. Make that a better dy. Anyway, the x component is like the shadow that would be projected on the x-axis, and the y component is like the shadow that would be projected on the y-axis. And it's triangle math, right? I mean, if we draw this triangle here, I'm going to draw it over here on the right. So we know this is 10, and we have this horizontal piece and this vertical piece that we're trying to figure out their values. But we know this angle is 45 degrees. So this is where SOHCAHTOA comes into play. Knowing trigonometry and your triangles is extremely important in physics. So if SOHCAHTOA and these right triangles is not something that you can do right off the top of your head, I really recommend that you practice SOHCAHTOA worksheets, where you have an angle and a side, or maybe you have a side over here and another angle, or this angle, and you keep working out the other pieces of the triangle. That is very helpful math in physics, okay? So for instance, in this case, since we know the hypotenuse, and let's say we're trying to find x, so let's see, we know the hypotenuse and we're trying to find the adjacent. Remember, this would be the adjacent side, this would be the opposite side, and this would be the hypotenuse side, because it's all based off of this angle. So this is, of course, the side opposite. This is the hypotenuse, and this right over here is the adjacent side, right? So now we can say, oh, cosine. Cosine is the one that deals with adjacent and hypotenuse. So we could say cosine of 45 equals adjacent, which is what we're trying to find out, which in this case is dx, over hypotenuse, which is 10. So therefore dx equals 10 cos 45. And that happens to be, cos 45 is 0.707, so this happens to be 10 times 0.707, which is 7.07. You could do the same math for the y. The y is opposite. Opposite is going to be sine because you know the hypotenuse. You want opposite and you have the angle. So you do the same kind of math. Sine 45 equals opposite, which is dy, over hypotenuse, which is 10. And therefore, dy equals 10 sine 45. But I want to be real careful here because this is pointed down and this one here is pointed to the left. So we actually have to be careful. And we can put the 7.07, but since this is over here in the negative x-axis and this is over here in the negative y-axis, these have to be negatives here. And so those components are both negative because they go left and down, and those are opposite to the positive axes on the coordinate system. Okay, what if we wanted to do 2 times d? 2 times d. So 2d, and I'm going to go in, I don't know, what color do I want here? I'm going pink. So 2d would be d, but twice as long. Kind of makes sense. So if that's d, 2d would go all the way to here. That'd be 2d. And so if you think about it, back over here, if I wanted to know what 2 dx and 2 dy are, they'll also be twice as big. This will be negative 14.14, and this would equal negative 14.14. So when you're multiplying vectors by a number, the vector just gets that big by, that multiple. So if it's 2d, it's not 10 anymore, it's 20. And what's interesting is the components also change by that same factor. So x and y so when you multiply 2d, x and y also get that treatment, and it would be 2dx and 2dy. Same is true if you wanted to multiply by a half. If you multiplied each one of d by a half, it would now become 5. And dx and dy would be 7.07 divided by 2. And it would, of course, be still negative because it's still heading in the negative x and the negative y. All right, so hopefully that helps clarify some stuff. Again, please come by. Let me know when you need a video on some concept because I'd be happy to find some time to make one, okay? All right, thank you.